o'clock on the dot. Here's what I want you all to do. I want you guys, and I'll share my screen. My sister, says Julian, made some homemade yogurt, so I'm eating it with granola. Good for you. That's a nice, healthy breakfast. That granola is going to have lots of sugar to get your body firing on all cylinders, and the yogurt's got good probiotics, also probably a lot of sugar, and so that's good way to get your day started with some good energy. Here's what you can do to get started here. I want you guys to go ahead and open up NextGen. You'll see that there's a 5-problem warm-up that we're going to use to get started this morning. I'm going to fire up GoGuardian to make sure that you guys are all getting there. So for those of you that I just let in, I want you guys to go ahead and open up NextGen. You will see a brief warm-up. It is titled Friday Warm-Up with the date, which is 1/29. It should be there waiting for you. I posted it earlier this morning. Okay, and where are all my classrooms? Interesting. All right, there we go. Cool. 4th period. No, I just want to start a new session. There we go. Cool. All right, boys and girls, for those of you just joining us, because I've let about 6 or 7 of you in the last minute or two, let's go ahead and open up NextGen. You're going to see that there is a Friday warm-up with the date, which is 1/29. Okay. So once again, because I've got people joining late, you're going to want to open up NextGen. You're going to want to look for the Friday warm-up, which is titled 1/29, and the first problem looks just like this. And I want everyone to go ahead and do this because I'm going to be calling on you guys. This warm-up shouldn't take us more than about 5 minutes. So we're going to whip right through it, and I need to see that everybody's participating. So if you are one of those select few who kind of like to hide in the background and not be with us, be prepared because I'm going to be calling on you. Okay, and I've got GoGuardian on right here. So it looks like Kevin is ready to go. Jeremiah and Desire are ready to go. Camilla is ready to go. Brando and Karen. Brando's not quite there. Logan is not quite there. Francisco and Samantha and Valeria and Rosalie are there. Julian is there. Logan is still not there. Okay, Logan and Brando, I need you guys to get with us. Isaac is there. Genesis is there. Armani is almost there. He's logging into NextGen. Maria's not quite with us. Maria, I need you to get with us, please. Is this going to be our NextGen for the day? Well, I guess that depends on how the exit ticket goes. If I see that you guys mastered the exit ticket and did it correctly, then I suppose you don't need much more practice than the NextGen that we do together as well as the exit ticket. But if I see a bunch of people bombing the exit ticket, then I suppose I have to assign NextGen. So I suppose that question will be most easily answered by how well you perform. So I see that almost everybody's with us. Logan is with us now. Brando is still logging into Zoom, and Maria is still logging into Zoom. So we will go ahead and move ahead while they are getting with us because I don't think that they are ready to go. Okay, so these should be fairly easy. Let's go ahead and start this off. I'm going to stop sharing, so it's going to be on you, okay? So when I call on you, you better be with us. So problem number 1. Let's start with Kevin. Kevin, can you read me problem number 1, please?
7 times 7 times 10 times 10 times 10 times 10.
Okay, you've got the actual number part right, but what you're missing is the instructions. Remember, we need to read what the yeah. Let's go ahead.
Use exponent to write the expression.
Okay, so use exponents to write the expression. Okay, so let's go ahead and do that. So Kevin, once again, read me those numbers so I can write them out in expanded form. Go ahead.
7 times 7 times 10 times 10 times 10 times 10.
So how many 10s are there? 4?
Yeah.
Okay. So let's go ahead and start. Let's go ahead and separate these into 2 categories. There's 4 or 5?
5.
5. Okay. 1, 2, 3, 4, and I'm missing one. I'll add it right here. Times 10. Okay. Now let's go ahead and separate these into categories. I see 7s here, okay? And then I see 10s here. So what do we think here, guys? If I wanted to take these expanded form notations and condense them down to exponential form to write them with exponents, how could I do this? Well, I could start by counting the number of each base, right? My cam is on Shayra. It shouldn't be. I tried to put it on mine. Hold on. There we go. Okay. So, looks like Julian has an idea. Julian says that we can write it as 7 to the power of 2 and 10 times 10 to the power of 5. We could write it just like that, right? Does everybody agree? Thumbs up in the camera if you agree. Thumbs up in the camera if you agree. Okay, good. Looks like we have unanimity. We've got consensus. Let's go ahead and enter that and move on. Okay, so 7 to the power of 2 and 10 to the power of 5. Okay, now, bonus question. When I have problems that are written to the power of 2, what is like the shortcut way that I said to memorize that? What's another way we can say to the power of 2?
7 squared.
7 squared. Very good. All right, moving on to question number 2 in our next gen warm-up this morning. Let's go ahead and have Shayra read me question number 2, please.
Okay, it says write 9 to the power of 2 using repeated multiplication. Then find the value of 9 to the power of 2.
Okay, so now we're essentially doing the opposite of what we did here, right? Now instead of moving from expanded notation to exponential notation, we are now going from exponential form to expanded form. We're working backwards, right? So let's go ahead and think about how we can do this. 9 to the power of 2. Well, Shayra, let me ask you a question since you read us the problem. If you had to determine the base in this problem, what would be our base? 9 would be our base, right? Because it's the number that's being multiplied by itself. And which number tells us how many times we're multiplying 9 by itself?
The 2.
The 2. And we would call this the what? The exponent, or the power, right? Exactly. And so how would I then take this and snap it apart like Legos so that I can expand it? How would I do that?
9 times 9.
9 times 9, okay? Now we're not quite done because it also says to then evaluate the expression, right? To find the value of 9 times 9. And those of us that have our times tables memorized, we know that 9 times 9 is
Of course, 81.
81. Very good. Okay, so go ahead and get that entered into your next gen. So far, you guys are making me think you might not need any more next gen practice after our lesson. But our lesson's going to cover some new territory. Okay, so let's speed this up just a little bit. We've got another problem that looks just like the one we started with. Let's go ahead and have Valeria go ahead and count this for us.
2 times 2 times 2 times 2 times 2 times 2 times 8 times 8 times 10 times 8 times 8.
Okay, so I count. How many 2s do we count here? I count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I count 4 8s. 1, 2, 3, 4. Very good. Okay, so Valeria, since I've got you on the line and I know your microphone is working, let's separate these into categories. Okay, and what would be my first base that we're working with? If we're taking this from expanded and shrinking it down to exponential, what would I do? What would be my base here, Valeria? 2. Okay.
And your exponent would be 6.
2 to the power of 6 times
8 to the power of 4.
8 to the power of 4. Do we all agree? Does everybody agree with this? Thumbs up in the camera if you agree. Oh, no, I just realized you guys can't even see that, can you? Oh, yeah, you can. Okay. Okay, Desire says, yes, we agree. And if you're finding this easy, I'm glad. It means that you are ready to move on to bigger and badder things. We need to move on to more complicated things. So let's go ahead and move on to the next question. Looks exactly like the first 2 that we warmed up with. We're now using exponents to write an expression, right? We're moving from expanded down to exponential. This one I want you to do on your own. This one you guys go ahead and do on your own, and then go ahead and type your answer into the chat log to let me know that you are ready to move on. Good. Shayra's already there. Good. Genesis is there. Good. Julian is, hold on. Julian, I think you mixed up your base, my friend. Camilla is there. Isaac, you did 10 minus 3. Remember, when we are representing raising to the power, there we go. Thank you, Julian. Good correction. Good, Valeria. Gabriella's got it. Karen's got it. Francisco's got it. Looks like we're almost all there. Natalie's got the first one. She missed the second one, though. Remember, Natalie, we're looking at two. We've got the first base and exponent, and then there's a second series of base and exponents. There we go. Thanks, Nat. Appreciate it. 10 to the power of 3 and 4 to the power of... is it 4 to the power of 3? It would be 4 to the... No, there's quite a few more than 3 there, Isaac. All right, so just for those of you that are confused, yes, we have a base of 10 in the first situation, right? And we raise that to the power of 3. And we also have a 4, which has been raised to the power of 6. Yes, exactly. Okay? And luckily for us, we're not asked to work this out, but we could if we needed to, right? All right, let's go ahead and move on to the final question in our warm-up. Another one just like these ones that we've been working on. Okay, once again, I'm leaving it to you. Go ahead and get it typed into the chat and put into your next gen. Okay, once I know that you've got it in the chat, I will know that we are ready to move on to today's lesson. Okay, okay, chat log's blowing up. Let's take a look. Chat log has it. Jesse's good. Camilla's good. Karen's good. Valeria's good. Shayra's good. Desire's good. Julian's there. Natalie's there. Krishma is there. Isaac, you're there. Francisco's good. Excellent, you guys. Excellent, excellent. So, let's see how we do with today's lesson and the exit ticket. If we're able to get through both of those in a way that is convincing to me, I will go ahead and count this as your next gen practice for today. Unless you guys want more. Do you guys want more next gen practice? Logan is violently nodding his head yes. And Julian looks like he's having a seizure, shaking his head no. Julian is emphatically insisting that we not. Desire has written no with like 12 O's. She wrote N and O to the power of 12. Yes, you may submit it. Let's go ahead and submit it and move on to bigger and better things. Now, this is what you're going to need to be successful. You guys can go ahead and follow along with me as I move through this, okay? So you'll notice, can I have, let's go ahead and have Miss Camilla F. Can you read me the title of this, the title card, please? Can you read this for me?
Equations order of operation.
Exactly. Okay. So notice we're still working with expressions and equations. Okay. But now we're moving on to the order of operations. Has anyone ever heard this term before? The order of operations. Okay. Good. I'm glad that you've not heard it because then I get to take credit for it when you guys are all math geniuses in your old age. Oh, Valeria says yes. Well, Valeria, I don't know that I could ever take credit for your genius. Okay. So here we go. Let's go ahead and get into what we're going to need to be successful here. You're going to need a whiteboard and a marker or a paper and a pencil. I would suggest for this one, paper and a pencil. That way you can write down notes. We're going to color code some things too. So you're going to notice at the bottom, you're going to need colored pencils. If you have markers, those will suffice. If you have crayons, those will suffice. But the 4 colors you're going to need are going to be blue. Okay, so blue. You're also going to need purple, you're going to need green, and you're going to need red. Now, if you don't have those 4 colors, any 4 colors will do the cake. As long as we'll do the cake. That's not even an expression. We'll do the job, okay? You can use pens. Karen asks if we can go, if she can take a second to go get her materials. Yes, so take 30 seconds to go collect the materials you need. 30 seconds. Clock starts now. It is 8:15.
What colors do I need?
You need blue, purple, green, and red.
Dark green or light green?
Doesn't matter. As long as you have 4 separate colors so that you can color code the problems that we work on.
So blue, purple, and green?
Blue, purple, green, and red. All right. Now, as always, we begin with our expectations. This way nobody can cry and say, I didn't know my camera needed to be on. I didn't know I needed to participate. Julian, hit me with my first lesson expectation. Let's go.
Listen and follow directions.
Alexis, number 2.
Actively listen and participate in the lesson, either out loud or through the chat.
Right. If you're in a loud house, you got brother and sister like Genesis, right? I don't mind if you use the chat. I would prefer talking out loud because it feels more human and less robotic, but I will take either. Number 3, let's go with Karen.
Practice effective and efficient collaborations. No sidebar conversations.
No sidebar conversations, and by now we also know that that means no sidebar activities, right? So if you've got your phone in your lap, if you're watching Disney Pixar movies on the side, or if you're watching, television, those are sidebar activities, and we're gonna go ahead and table those for just a minute. And as always, cameras on, and at all times we do what, Mr. Kevin? At all times we do what?
Which expectation is it?
It's the last one.
Soar at all times.
Soar at all times, right? That's right. Thank you, Krishma. We show respect, we're on task, we're acting responsibly, and we're reaching for personal best so that when we do come back, it is not a complete and utter farce, right? All right, so now on to our objectives. Well, you guys have mastered the primary objective from earlier this week. You guys know how to write and evaluate numerical expressions with exponents. You guys have done this. You just showed me you can do it. So whether or not you truly believe you can do this, those of you that got through the warm-up and were like, this is pretty easy, we're kind of banging on all cylinders now, you guys have the primary objective of this standard mastered, okay? Whether or not you have your times tables and your math facts memorized is a whole other set of issues, and we'll get there. But the secondary objective of this part of the standard is that we need to understand the order of operations and its kind of influential role in how we evaluate expressions. And if that sounds like a mouthful, if that sounds confusing, don't worry. We will go ahead and we're just going to knock right into it. So let's review what we already know. Well, we already know that when we're working with expressions, we've learned about exponents and that we have 2 parts to every exponent. The base, which is what? What is the base? Krishma, can you read me the definition of a base, please?
The base refers to the numbers that is multiplied by itself.
Exactly. It refers to the number that's being multiplied by itself, right? When we raise it to a certain power. So Krishma, for instance, if I had, and again, I'm sure that you guys have this mastered, if I wrote 4 to the power of 2, which one would be my base, Krishma, the 4 or the 2? The 4 would be my base, exactly. So this is my base, okay? And that leaves us with the second part of an exponential expression. We have the exponent or the power. And let's go ahead and have, who have I not heard from this morning? Francisco, can you read me the definition of an exponent, please, or a power?
Exponent power refers to a number that shows how many times the base is multiplied by itself.
Right, so exactly. We can see this as a series of instructions, right? The 4 tells us that we're multiplying 4 by itself. The 2 tells us how many times. So in this case, we would have 4 times 4, which would have a value of 16. So this is what you guys have mastered. This is what I wanted to show you. Before you guys think you haven't mastered this, and you guys get all down on yourselves, which you guys are often want to do, you guys have this. This was our sole focus of the week. And so I figured we are ready to move on to this. Order of operations. Now, here's what I want you guys all to write on your notes, your page, okay? I want you to write, at the top, I want you to write in whatever color you'd like, order of operations. Okay? And we can put in parentheses the recipe for evaluating expressions. Okay? Those of you, how many of you like to cook? I know that some of you. I know Valeria got into cooking breakfast pastries. She was making crepes. Shayra likes to cook. Who else likes to cook in here? I've watched Isaac. Isaac likes to cook eggs in the morning. Karen cooks. Alexis cooks. Krishma cooks. Yeah. Okay, good. So this will be an analogy that good. Rosalie cooks. This will be something that kind of, I think, hits home with you guys. Gabriella says my sandwiches. And Gabriella, do you remember what my nickname was all throughout college with my family? Sandwich boy. Sandwich boy. Yep. I worked at every conceivable sandwich chain you can imagine. I paid my bills in college by working as an assistant. What was my title? Assistant to the GM. I was like Dwight Schrute from The Office, right? For Panera Bread, right? I went home smelling like flour and yeast every single day. Okay, so now that we have this written at the top of our page, I want you guys all to take a look at this nifty little acronym that I've provided for you. And I want you to write it out using your color code. So first I want you to write P in blue. I want you to write E in purple. I want you to write M and D in green. And I want you to write A and S in red. I want you to go ahead and do this. Okay. Take a second to get that done. Now, we're going to go ahead and discuss what this all stands for in just a minute. This acronym, PEMDAS, if you are one who struggles to memorize acronyms, get ready because you can always remember it by using this term. Please excuse my dear Aunt Sally, right? Maybe Aunt Sally is a messy eater and you brought her to a friend's house for Thanksgiving dinner and she's making a mess out of her food. Maybe Aunt Sally has a hard time not burping while watching movies. Maybe Aunt Sally is just a rude person, right? So we need to remember that sometimes Aunt Sally is in need of some grace. And so we need to remind our friends, hey, please excuse my dear Aunt Sally. She doesn't know any better, right? So try to remember that part. Please excuse my dear Aunt Sally. Okay? What does the title say after the, oh, there we go. Evaluating expressions. Sorry, my handwriting is sloppy when I write in marker. Okay? Good. Gabriella is saying she remembers this from 5th grade, as does Karen. Valeria says that she has used this. Julian is saying he used this. And Kevin has just told us that he has used this as well. Good. That means you guys are going to take even less time to master this. Now, here's the deal. Since some of you have a working understanding of this already, let's go ahead and what do these each stand for? Let's go ahead and write these out. What does the P in PEMDAS stand for? Parentheses, right? So we can go ahead and draw a pair of parentheses here, okay? Now this also is going to include things that are called brackets. And brackets are basically parentheses that exist outside of parentheses. And there are these square looking angular, more kind of stark looking parentheses, and we'll get to those. But right now, just remember that the P stands for parentheses. Okay, then what does the E stand for?
Exponents.
Exponents, right? So we can say, we can just draw a little picture of a base, and in this case, we'll just call it A, and then we'll raise it to the power of 2, or square it, right? All right, well then that leaves the M and the D. Let's go ahead and bring those down here as well. What do the M and the D stand for? Multiplication. And what does the D stand for? Division, right? Okay. Now, the A and the S, what do these stand for?
Adding.
Yes. Adding and subtracting, addition and subtraction, right? So, Now that you understand that these are all the different operations that you have learned about over the course of your academic career, we know that the order of operations, what does it mean to put things in order? If you're like my daughter, when she puts her crayons away, she has to put them in rainbow order. That's her thing. So they have to go red, orange, yellow, green, blue, indigo, violet, and so on. What does it mean to put things in a specific order?
To put in a certain pattern.
Yes, right? To put them in a certain pattern, or to put them in their proper sequence. Okay? Or steps. Now, what I mean by that is this. I want you to look at this slide here. Look at the picture on this slide. What do you notice about the cake on the left versus the cake on the right?
All one's messed up on the left and one's not on the right.
Right, exactly. The right cake looks nice and fluffy. It is risen properly in the oven, right? And the left one is all lopsided. It looks like maybe someone couldn't stop opening the oven, and so maybe it didn't bake evenly, or maybe the oven has not been calibrated, or maybe, just maybe, the person who baked this cake did not mix the ingredients in the proper order. So when we're evaluating expressions, it's important that we understand that there is a proper order in which we must work. And when we fail to do this, it's going to result in wild calculations that don't reflect the true value of our expression, right? And so the simple analogy that I can give you, the simplest, can be found when we cook a meal from a recipe, okay? And what happens to our meal when we fail to follow the step-by-step instructions when we're cooking from a recipe? Sometimes we just cook by experimentation and we get lucky and we get something delicious, right? But if we're cooking from a specific recipe and we don't follow a certain step, maybe we don't let something saute long enough, or maybe we don't let something bake long enough, okay? Valeria says it comes out all wrong. Exactly, okay? Now here's another analogy, okay? So I want you to imagine, you guys are 15 and a half years old. You're finally getting your learner's permit, okay? And while you have a pretty good grasp on some simple aspects of driving, you know green means go, red means stop, right? You find that the rules of the road are really confusing when you dig into the specifics, right? And they're difficult to memorize. You're sitting at your driver's test and you're like, oh my God, what's the speed limit in a school zone? Do I speed up to hit the kids? Do I slow down to miss the kids? Am I going slow enough, right? How long do I need to put my turn signal on before I make a turn so that the people behind me don't accelerate and smash into the back of me, okay? What if it's raining? How much am I supposed to reduce my speed? Okay, what happens when we don't know the rules of the road when we're driving? What do you mean it goes wrong? What happens, Jesse? If I don't know the rules of the road and I get behind the wheel of a car and I just start driving however I want to drive, what might end up happening? You crash, right? Mayhem ensues. People wind up losing limbs. All kinds of stuff, right? So, luckily for us, when we're solving expressions, which is kind of like, you know, driving. Luckily for us, we have PEMDAS, okay? We have this nifty little acronym to tell us what the rules of the road are. And so what I want to do is watch a brief video.
Here's a new way to learn math that's fun and interactive.
And we're not going to watch the whole thing.
Exploring
Hold on.
concepts visually and
There's the ad. There we go.
Hi, welcome to Math Antics. Today we're going to talk about an important math concept called order of operations. Order of operations is just a set of math rules that tell you which math operations, like addition or multiplication, to do first. Now you might be wondering, especially if you're a teenager, why do I need rules to tell me which operations to do first? Can't I just do them in any order I want? Well, that's a really good question. And to answer it, we're going to give two totally different people the same math problem to solve. The problem is 2 plus 5 times 4. I like addition better than multiplication, so I'm going to do that first. Let's see, 2 plus 5 gives us 7, and then I just multiply that 7 by the 4, and I get 28. That was easy, but you'd better not copy my answer. Don't worry, I'm not going to copy your answer because I want the right answer. And I prefer multiplying, so I'm going to do that first. Let's see, 4 times 5 equals 20. And then I'll add the 2, which gives me 22 for a final answer. What makes you think that's the right answer? All my calculations were correct. I even checked it with a calculator. Pfft, the only calculator I need is right up here. And the correct answer is boop, 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 22. Okay, so which one of these guys do you think is right? Neither one made any mistakes with the calculations. They just did the operations in a different order and got different answers.
Okay, so here, so just for the sake of time, because we're not going to watch this entire video, who do you think got the correct answer? I want you guys to go ahead and type the correct answer. Was it 28 or was it 22? I want you guys to type it out in the chat log. Desire said, okay, good. Desire, you know what I love most about you is that even when you know the answer, you present it with like humility. You're like, I want to say it's this, but I don't want to be wrong, right? I love that about you, that you're always humble with your answer. All right, good. Now, you guys have this. The correct answer here is 22. And let me explain why that is, okay? If we look at our order of operations, which comes first if we're reading from left to right, which those of us who read and write in English and Spanish, okay, we know that Hebrew goes the other way, but in terms of this, we go from left to right. Which comes first if we're looking for addition? Multiplication comes first in the order of operations. So therefore, we need to solve that step first, okay? Multiplication comes first. Now, let's go ahead and move on so that we can get to our exit ticket and get you guys out of some pesky next gen. So let's read this problem below. Let's go ahead and have Isaac, can you read me the problem below?
Michael, Morgan, and Keegan are in the same class. The teacher asks the students to write and simplify the expression 6 plus 4 cubed. Here are how the expression each person wrote.
Okay, good, thank you. So, go ahead.
Which student will make the correct answer? Which and if in any way of the expressions are equivalent? Explain.
Okay, good. So before we start to get into this, let's cubes this out. Let's go ahead and cubes this out. Now, I'm going to go ahead and help you with this cubes. I'm going to model how this should go, okay? So, I'm reading the actual problem itself, and I know that my important numbers are 6 plus 4 cubed. Okay, that's all the information I have right now. Now the problem is asking me to perform a specific task right here. Okay, and what is the problem asking me? It's asking, so I need to know which student is correct. Okay, so each of these students wrote his or her own answer, and it's our job to determine which one is correct. Okay. Now we're going to box important signal words. What signal words did you guys notice up here? I see plus and cubed. Okay. So plus equals, we know that that's addition, right? And cubed means that we are going to raise to the power of 2. Okay? I don't really see anything we can eliminate, but now we can kind of dig in and solve and see what it is that we need to kind of unpack here, okay? So, let's take a look at Michael's. Well, let's look at Michael's. Michael's is written like this. Michael wrote his like this. 6 plus 4 inside parentheses raised to the power of 2. Okay. Oh, I'm sorry. Cubed, not squared. That's raised to the power of 3. Go ahead and fix that. My bad. Okay. Well, let's go ahead and look at Michael's here. What would I do first in this situation?
4 and 3.
I would do 4 and 3 as
4.
exponents first.
I would do 4 squared by 3.
You mean 4 raised to the power of 3? Okay.
Yeah.
I'm glad that you're thinking on your feet, Julian. However, remember the order of operations. What does the E stand for?
Exponent.
Exponents. But do you see something that comes maybe before the E? Something that we need to get done first. The parentheses, right? So, if we want to go this route, we have to add 6 and 4 first because they are inside the parentheses, okay? So, we can add those first, and what we get, what is 6 plus 4? I just gave you the answer. 10, right? And then once we do that, we can get rid of our parentheses, and what's left over is 10 to the power of 3. And we know how to write that out. That's 10 times 10 times 10. And by now, we know that that has a value of 1,000. Okay, so that would be Michael's. Now, the question asks, why do we add 6 plus 4 first? And the answer to that is because the order of operations says we need to perform parentheses, if there are any, first. Okay? Now let's move on to Morgan. Now Morgan wrote hers out a different way. Morgan wrote 6 to the 6 cubed plus 4 cubed. Okay, let's solve this how Morgan does it. What would we do first? Well, what are the two operations we see here? I see addition and I see exponents. Well, which one comes first in our order of operations? Exponents or addition?
Exponent.
Exponents. So let's solve these first. We can write this out as 6 times 6 times 6 plus 4 times 4 times 4. And we can work these out. 6 times 6 is 36. And let's go ahead and do 36 times 6. 6 times 3 is 18, plus 3 more, 19, 20, 21. So we know we have 216. And then 4 times 4 is 16, and 16 times 4 is what? Do you guys have that one memorized yet from doing these? 64. I had a feeling you would. So we'll bring that one down as well. So now we have 216 plus 64. Okay, and we can add those together. 6 plus 4 is 10. 6 plus 1 is 7, plus 1 more is 8. And 2. So we know Michael got 1,000 and Morgan got 280. But wait a second, they're using the same numbers, they're just doing them in different orders. Now, let's go ahead and take a look at how Keegan did his. Keegan's looks like this. 6 plus 4 cubed. There we go. What would I do first here? What are my two operations that I see?
Multiplication and adding.
Okay, well, I do see multiplication in the form of an exponent, but remember, for the sake of PEMDAS, we need to be sure. We need to be precise. Yes, I knew what you meant, but we need to be precise. So what is 4 times 4 times 4?
64.
Right, so we get now 6 plus 64. Which would be 70.
70.
So I want you to pay attention to this. So Michael, he evaluated his and got 1,000. Morgan got 280. And then we have Keegan, who got 70. Now, they used all the same numbers. They just solved them in different orders. They used different means of solving this expression. So, the teacher says the expression equals 70. Which student got it correct? Yes, Keegan was correct. Exactly. Okay? Now, how might the teacher have said the expression if she wanted the kids to write it the way Keegan did it? And remember, Keegan said 6 plus 4 cubed. She could have said, anybody have any answers? Anybody want to throw it out there?
6 raised by the power of 4.
Not raised by the power of 4. What they could have said, if they wanted to be precise, she could have said, I want you to find the quantity of 6 plus 4 cubed. Okay? Ooh, not equals, plus 4 cubed. Okay? Now, this is kind of a minor difference, right? But this is the kind of stuff that mathematicians quibble over. This is the kind of stuff that your teachers are going to hold you responsible for. They're going to say, hey, wait a second. I told you to find the quantity of 6 plus 4 cubed. Okay? So, let's go ahead and take a look at this one here. Let's look at our buddy Corwin, and then I'm going to release you to do your exit ticket. Your exit ticket is going to be fairly easy, and I'll make you a deal. If I see that 70% of the class, those of you that are here taking it now, are able to use the order of operations to get the expression correct, I will cancel next gen. So be paying attention here. Corwin tries to evaluate 4 squared times 5, and that little dot right there is a multiplication sign. And I want you guys to take note of that. That dot right there means multiplication. I'll get into why we're using a dot instead of an X next week when we get into algebraic expressions, okay? But for now, 4 squared times 5 plus 6. Now let's look at how Corwin broke this down. It looks as though Corwin, instead of, well, what do you guys notice? His first step is he now has 4 squared times 11. What did he do first? What do you guys think he did first?
He added the 5 and the 6 together.
He added the 5 and the 6 together instead of doing what? So what Jesse just told us is this. Corwin started here. Where should he have started if we have our order of operations? And let me go ahead and write it out here. PEMDAS. Where should he have? Well, should he have? He should have started with the exponent, correct. So let's go ahead and explain why his answer is incorrect. Corwin began by adding 5 and 6. Instead, as Jesse just told us, and as Julian just told us, he should have started with the exponent, then gone where? What should he have done next?
Then he should have multiplied 16 times 5.
He should have multiplied 16 and 5. Okay, finally, he should add what? What should he have added? Well, let's go ahead and work out what is 16 times 5. What is 16 times 5, boys and girls?
80.
It is 80, right? So then he should add 80 and 6 to find a value of 86, okay? Good. It sounds like you guys have this. It sounds like you guys are ready to rock and roll. So here's what we're doing. So to close, just so that we're all on the same page, we need to remember there's a specific recipe we have to follow. First, you want to look for parentheses. Okay, if there are none, no big deal. Then you want to look for exponents. Again, if there are none, no big deal. Then you want to move on to multiplication and division, and you can do either one. Notice they're both in green. You can do either one first, okay? And then we move on to addition and subtraction last, okay? So, here's what you're doing. It's 8:45 now. You can either find it at this link or you can find it in Google Classroom. You'll notice it's very simple. What does the P in PEMDAS stand for? What does the E, the M, the D, the A, and the S, okay? And you don't have to answer in full, complete sentences. You can just write them out. But the one I'm really looking to see is this one here. If you get this one correct, if I see 70% of the class got this correct, we don't need next gen. Now I'm going to draw your attention to something. This fraction bar, I put that the wrong way. This fraction bar, I'm sure, is going to confuse you. Now remember, fraction bar is just another way of saying divide. Think of this as an improper fraction. If you solve everything up here, well, we'll go ahead and see how you do. We'll see how you do, okay? I want everyone to do their best, okay? Do your best, and I want you guys to submit your answer as soon as you can. When we come back for fifth period, we are going to work on the Westing game. Capiche? All right. Get it done, boys and girls. Have a nice one. See you in about an hour and 15 minutes.
Wait, if they talking when they say what is the P for? Didn't we just write that down?
You did, so you can use your notes. That's why I asked you to write it down.
Oh, okay.
Okay. Bye.